And we're
Okay. Should we wait a few minutes for a few other people to join, Barry, or you have a list still, or should we just go ahead?
26.
20, are there people still in the waiting room, or are they?
Yeah, we keep admitting them. Yeah.
Okay, shall I wait? I'll wait a couple of minutes then so everybody shows up before I.
not too long.
Right. Okay, Barry, I think we have everyone in.
Yeah,
Or should,
we'll keep admitting them as needed.
okay, so I'm going to start for the sake of keeping to our schedule. So, hello, everyone. Good afternoon, or if you're across the Atlantic or Pacific, whatever time of day it is for you, welcome. Um, this is a webinar sponsored by the North American Natural Science section. My name is Mark Riegner, and I'm on the coordinating committee of the Natural Science section here in North America. And our presentation today will be approximately 45, 50 minutes by Frank Fawcett, and I'll say a few words about him in just a moment. And then afterwards, we'll have about 30 minutes or so for questions and discussion. But Frank is also open if somebody has a real pressing, burning question during his presentation, you could click a comment or raise your hand digitally, and he could address that. But otherwise, we are reserving time at the end of the presentation to have questions and discussion. So today, just one other point about our webinar series. So we're very pleased to have Frank Fawcett with us today. Uh, and then we have a whole monthly series of webinars coming up for you. Uh, in August, on August 15th, Michael Judge will be speaking to us, and he on a similar theme, looking at evolution, Earth evolution, and reconciling some of Rudolf Steiner's thoughts and ideas, presentations about that. So that's coming up on the 15th, keeping to this theme of evolution and geology that we have. And then in September and October, we have the return of Dr. Ari Boss from Holland, who has spoken to us before. He's an anthroposophical medical doctor with a background in neuroscience, and he'll be giving us two webinars monthly back to back. And then afterwards, later on in November, December, we'll working on some speakers to talk about the theme of color based on Goethe's color theory, as well as extending that into other areas. So that's coming up for us all on a monthly basis. Um, sorry, I have to close the window. There's a plane flying low. There we go. And okay, so today we're pleased to present Frank Fawcett, who will speak to us regarding how a number of Rudolf Steiner's descriptions of world evolution relate to the phenomena of geology, that is, to what the rocks have to tell us. Frank lives on the East Coast. In earlier years, he had been an engineer and a math special ed teacher. At age 50, he decided to return to college to study geology with the specific intention of reconciling the earth sciences with statements Rudolf Steiner had made regarding Earth evolution. And that's what we'll be hearing about today. That intention eventually led Frank to the work of German geologist Dankmar Bose and ultimating to translating Bose's 512-page book from German to English, published in 2019 by Steiner Books. And I have it here beside me. It's almost a workout just lifting this book up. It's a big tome, lots of incredible information here, and a remarkable project for Bose to write the book and then for Frank to be the translator of this, massive book. So if you don't already have it or interested, here it is, available through Steiner Books. Um, During that project, Frank Dankmar Bose, and another colleague took a 3-week field trip across the American Southwest, where the geology is just stunning, the Grand Canyon being a case in point. And I live in the Southwest. I live in Arizona, and I can speak to that. It's just remarkable geological features here because of the dryness and aridity. We don't get a lot of dense plant forest coverage on mountains and other areas, canyons. So you really get to see geology speaking forth without being covered up by much vegetation. So maybe Frank will refer to that 3-week field trip during his presentation today. So without further ado, we welcome Frank Fawcett, and I will mute myself and sit back and listen to what he has to share with us.
Well, thank you very much, Mark. As Mark mentioned, I went back to college to try to reconcile geology with anthroposophy. And when I got out, I realized the heavy lifting had been done by this German geologist, Dankmar Bosse. So I helped translate the book. I did a lot of it, not all of it. In this talk, I'm going to start out talking about Barry, do you know how that can be changed?
Someone may have
You all
unmuted.
set. It's somebody unmuted themselves, and so they're back to being muted. It creates an echo, so please do not unmute yourself until we're done and into the Q&A. Thank you.
Frank, you're muted.
Right, Frank, you got to unmute yourself.
How about this? Is this audible?
Perfect.
I'm not, you have to unmute me because I'm not muting myself.
You are unmuted now.
Can you hear me? Hello.
Yes.
Yes. Okay. Mark says he can hear me. Okay. I think most people who are listening to this know who Rudolf Steiner is and the work that he's done. Outline of occult science or an outline of esoteric science gives a good brief kind of overview of the evolution of the entire Earth sequence, but also of Earth evolution. And many people have looked at these charts that people have made going through the different incarnations of the Earth. But and I'll say we're going to be only involved with Earth evolution because during the Pralaya, all matter is disappeared. So everything we see is simply from Earth evolution. In addition to that book, Rudolf Steiner gave a lot of lectures that add details. This picture, for instance, comes from Lemuria, the changes in the human being after the Luciferic interaction. But the best images quite often are from the first Goetheanum. I copied this one because it's the only color print I think that's left from the first Goetheanum. It's beautiful plant colors. By the way, Mark, can you hear me well enough? Just good, okay. But more useful is, this is a drawing Rudolf Steiner made for Lemuria to help the painters. And I think it's good just to note what kind of animals are visible. These are probably either spiritual beings or human beings that haven't incarnated. I couldn't say, but you get an impression of the time that's being involved. And the one for Atlantis also, you see a kind of ruminant animal and I think what looks like a bird. Because there's a controversy in the anthroposophical world about the timing of Atlantis and Lemuria, and those can help us later on. Well, every quest for knowledge, I think, according to Rudolf Steiner, should start with wonder. And so the Earth certainly gives us plenty to wonder at. This to me is one of the beautiful sights from England. You can see this if you go to Emerson College. It's a hop, skip, and a jump down to the coast. All tiny fossils of limestone with beautiful flint nodules. And then huge areas that are flat on the earth. Here's the Mississippi and the Missouri coming together, I believe. The Himalayas. Well, where do we see the phenomena? You can see rocks in a stream bed. You can see them on the coast of the ocean. This is a famous outcrop used by James Hutton at Sychar Point to show an angular unconformity. And I think you can see here the rocks are kind of vertical going this way. Here they're a little bit horizontal. And he realized the Earth is not young. This took a long time to build up those strata, tilt them, erode them, put new ones down. So that was a significant outcrop. Of course, we see rock through mining and the actual landscape itself, just the form of the earth. There's a reason for everything that's there. And it's not well understood, but that's another interesting aspect. I just wanted to add a few more details to show how much has been researched on the Earth. My neighboring state of New Jersey is interesting to me because it, I think, has good evidence for flooding. But they have taken the time to analyze the sand and silt and so forth on the surface of the whole state and group it into phenomena, they can give times to it. So a huge amount's been done that you can use in geology. Oil drilling has made the sedimentary layers of the earth very well documented. Not much drilling into the crystalline basement, the rocks underneath the sedimentary rocks, but the Russians did go down, I think, about 8 miles. The deepest mine is about 2 miles. The deepest well is 8 miles. I guess it's worth knowing that we don't really know that much about the interior of the Earth. This is a kind of a rough sketch I did for a class. 8 miles doesn't really put you even through the gneiss and the granite, hardly. And they found quite a few surprises when they drilled. So I would say that the interior of the Earth is a bit of a puzzle, but you can do some things with the evidence given by the way earthquake waves travel through the Earth and are recorded by seismographs. So depending on whether the pressure waves and the side P and S waves, one sideways and one going straight, whether they go through a liquid or not, gives some idea what's in the interior of the Earth. But there's a lot of imagination goes on, I think. Another phenomena I don't think people look at enough is these huge slabs of granite and other stone that's used for countertops. My countertop in my kitchen, for instance, has very interesting granitic features. So if somebody gets interested, be sure to check out those stores. And I wanted to notice the banding phenomena. Particularly, this is from a gold mine in California. This kind of banding will be useful later, and also kind of hollows filled with crystals. All phenomena from the Earth. And another set of phenomena that showed up, people got interested in the 1700s, um, fossils. And at first they were curiosities, but people started realizing, these were living forms, and at different depths you find different fossils. So the first person to make a geological map in England, William Smith, worked on canals, and they would go through limestone regions sometimes, and there was one limestone strata that had particular fossils, and another limestone stratum had different ones, and he could tell where he was based on the fossils. They changed over time, and people came up with the idea of evolution, that animals started simply, got more complex. There was the idea, kind of natural actually, that it was aiming towards man and finally achieved it. But Charles Darwin came along in the 1800s, and he pointed out that, people have been altering animals purposefully for a long time. You can breed a small poodle for your sister to have, safe little dog, or a German Shepherd to guard your house, and who knows what if anybody comes. He said, well, you could create all of the species that we have because nature selects. We don't have to do it. Nature eliminates some creatures and forwards others, and that explains, well, everyone knows Darwin. And another last phenomenon I'll bring in, I guess it's not exactly a phenomenon, but radioactivity can be detected by machinery and used to date the age of rocks, and it opened up this whole lower era, which is billions of years old, now can be kind of sorted out. So there's a lot of phenomena. I think I will not go into that one. Well, what did people know about the Earth in the earlier days? Well, the Egyptians could certainly work with rock. Barry, can you tell me that all is going well and you can hear me? Could you unmute yourself and just say that?
Yeah, absolutely. It's
Okay,
going well.
great. It's
I can
going
hear you.
well. Okay. So the early interest was largely in metals, the Bronze era. The Romans could work with stone. They were great engineers. Came to the Iron Age. In the, I believe it was 1700s, the Kant-Laplace theory kind of gained acceptance that the Earth had started from a big nebula of dust, contracted, kind of threw off the planets, ended up with the sun in the center and the Earth going around it. That's still more or less the current view. In the 1800s, really, geology got going with James Hutton's considered the father of geology in the English-speaking world. But there was a lot going on in Germany as well. I won't go into it. But Hutton's ideas prevailed. He could see that rocks could be molten in a volcano. Apparently, it was quite hot in the depths of the earth. It was pretty obvious. He found granite intruding into gneiss up in Scotland, and he said to himself and to the world, that granite was molten. You can tell because it pushed up as a liquid through the gneiss. So we got the concept of an igneous rock formed out of a melt of material. So forgive this amateur production here, but the idea is, this is Hutton's picture, I believe, is that the land was slowly being weathered down. The streams would carry sediments into the sea. Here's sort of a cut into the sediments. As they get buried, they get hotter, the pressure's greater, they begin to metamorphose, minerals change. If it gets deep enough, they'll melt. That's where our granite comes from. So this was Hutton's idea, and I'm not going to actually go into the problems with that right now, but Mr. Bossa does quite a bit. But this is a landmark, I think, in geology. Everybody knows it. Igneous, metamorphic, sedimentary, all concepts coming out of an inorganic view of life. And just to interject, this is something more in line with Dagmar Boss's thinking or Rudolf Steiner's. Primary is derived from living substance. Secondary is broken up pieces like sandstone. But let's see, go a little further. There was another, I'm going to stop it for a moment. And Barry, could you look and see if anybody has a burning question? Because maybe they do. And if not, we'll go on. But they may need just to say it.
Yeah. Now I only see a hello all in the chat. And if anyone does have a burning question, they can use the React raise hand like that. Then you can lower your hand afterwards.
Okay, I'm going to go on, assuming that either people are asleep or they're too shy to admit that it doesn't make sense. So in the 1800s, this theory was being derived about igneous, metamorphic, sedimentary. But at the same time, chemistry was being, you might say, evolved rather quickly. And one man started investigating things that he called colloids. And they weren't solids or liquids or gases. He started, I mean, he worked with diffusion through membranes. If some substances wouldn't go through a membrane at all or very fast, he named them colloids, colla meaning glue. And if you look back at well, I can't get back so easily, but you remember that tree gum, that was a typical sticky colloid. And they behave differently than other substances. They don't crystallize, they don't melt. Instead, they do things like curdle, coagulate, flocculate. They also form spherical forms at times. And he thought, and I think he was actually right, that there was a dynamic, something going on within the material. He thought it was a kind of life force. And I'm inclined to say that too, that the substance comes from a living material generally and hasn't fully died. Yeah, there's the gummy. This is considered, by Graham, this is considered the kind of archetypal colloid is gelatin. This is chicken gelatin, and you've all probably seen it. If you boil a piece of meat in a pot and then put it in the fridge, the water will have fat on the top and the water itself will become gelatinous like this. And of course, you can make jello out of it, but it's not a solid and it's not a liquid. Egg white is another common colloid. Starch is a colloid. Pudding makes a colloid. Clay actually is a colloid. Horse's hooves, which you make glue out of, sticky. That's a colloid. But actually,
Say, Frank?
everything, yeah.
Oh, we do have a hand up
Okay, let's hear. Could
from
you
Jeff.
say your question and like see if we can go into it? Can you unmute them?
Unmute yourself, Jeff.
There we go. Hi, Frank.
Hey, Jeff.
This is extremely interesting. There was something that you said earlier on and is commonly accepted, but I read I wish I knew the source, but Steiner gave a lecture about the kind of dating of the geological uh, uh, qualities of the earth. And he said specifically there that modern geologists they do a dating, some kind of dating, scientific method of dating, but kind of suggested that the earth isn't all that old. Are you familiar with that? Or um, I
Um,
I can look for
yes.
it. Okay.
And I'll tell you, it's such a confusing topic and so involved that I've stayed away from it.
Okay. It's
So
just
I'm
like,
going to just tell you that. It,
uh,
it's true. It needs work. I'll talk a little bit about it in in the rest of the talk, but that's a sticky point
okay,
because
thank you.
yeah.
Yeah.
Okay.
I,
So now you can lower your hand and mute.
right. And I would,
Thank you. Thank you.
I will suggest that what Jeff's getting at is that the conditions of time has changed over the course of evolution so that the rate at which the radiation or the uh, the oh, come on, Andrew, my thought has stopped. The degradation of the material by radiation is not a constant, is one of the possibilities. And so for these dating things to work, they assume that the rate has stayed the same.
It's true.
Uniformitarianism or whatever.
There's a
Yeah.
lot of assumptions built into it. So, the fossils give a good way of dating rocks that gives you a nice spectrum. You can place everything pretty well. The years come from radioactive dating, and I just leave it aside for now. You know, the next generation can solve that one. So anyway, colloids actually can be formed by radiolaria. There's skeletons made out of opal, which is a colloid solid. Well, Thomas Graham was in the 1800s, but Goethe got involved with colloids, actually. Here's one of his statements. I'll read a little bit of it up here, because solidification in a colloid is not the same thing as crystallization. A melt hardens and crystallizes. That's one thing, happens at a moment. But solidification is a slow process in a gel. For instance, he gives an example. We see before us a liquid that seems completely homogeneous, milk. A slight change of circumstances, you put rennet in it, for instance, causes it to decisively curdle and the separate parts appear. They're related to each other, but nevertheless separate, all the while continuing to contain portions of each other. So anyway, I've got a video of hardening. I don't know why I put it there, but here's a melt. It's kind of mirroring my garage there. It's still a melt, still liquid. And then at one point, it crystallized. Hardening and crystallization for a melt, same time. But here's Goethe. This is curdling milk in the process of making cheese, I guess. You get the curds and the whey. So he says, I think developments of this kind are to be found in the mineral kingdom more often than is generally thought. So he was active in geology. I guess you know that. Mr. Bosse got quite a bit from Goethe. And what happens when you have a piece of cheese? There's something that it doesn't crystallize, it just gets harder. You can get a piece of cheese to be as hard as a rock. So that's how colloids harden. And this is a piece of marble that was from Goethe's collection. And it can be done. You can see that it hardened kind of in a dark form, I think, and then was jarred, turned liquid, the lighter part flowed. Anyway, you can read phenomena out of a hardened colloid. And regular geology recognizes that certain elements or certain minerals are formed in colloidal states sometimes. That's a iron, a hematite, I think. That's considered, the dendritic is considered colloidal, botryoidal. This is considered, so geology knows about colloids, and it's actually a big subject in veins, mining veins, mesothermal vein systems. You know, it's kind of a side subject. Everybody's into melts, but there's a few people that say, hey, there's colloidal stuff. Best initial precipitation of amorphous silica gel, colloid. So the idea is out there a bit, but mostly it's talking about just little tiny phenomena. But how about this granite and gneiss? This, Mr. Bosse claims, is colloidal also. So I'm going to talk about Mr. Bosse now for a little bit. Then we'll go back to the colloidal subject. But I think, I'll give another opportunity to raise your hand if you want. Does anybody have a question about that part? Because this distinction between melt and colloid is extremely important for Mr. Bosse's book, and we'll get into how he reasons.
It was a good demonstration.
Okay, so keep going. Anyway, Mr. Bosse, there's from the book. He's a kind of an aristocratic. He has a little bit of an aloof, stern side, but he's also quite friendly. There's him that was in the Front Range. He flew into Denver with his friend, and there we are looking out from the side of the Front Range. He is. Now, I wanted to say something about his life. That to me, it's kind of a destiny is kind of written there because he was born to anthroposophical parents in the town of Weimar, which was Goethe's town. Steiner spent a lot of time there too. Goethe was very important for this geology work. When we visited, that's the house that Goethe's rock collection is held in. And there's Mr. Bosse back there smiling away. He knows Weimar inside out. He took me. This is in Goethe's house. And he made a great point of showing, Goethe was right up with the times. This is a chart that Sedgwick or Murchison, one of the geologists from England, came and visited him and brought the strata of the Jurassic period. They were just working it out. He was right on the forefront. And over here on the other side is, Mr. Bosse points out, is his barometer. He followed the cycles of the atmosphere fluctuations quite carefully. And Mr. Bosse, with the juxtaposition, he says, Goethe knew that these strata that came down in rhythmic processes, that was somehow related to the barometric phenomena. There was something, rhythmic there. Well, Mr. Bosse went to the best school in Germany, I would say, for geology in Weimar, Freiburg, the Freiburg Mining Academy and Technical University, established 1765. Werner taught there. Mining had been going on in Freiburg for centuries. And Mr. Bossa, I thought this was just a funny story. He was given as a student, well, go out and map the brown coal. It's a big important deposit in Germany. And the same exercise had been given to Novalis. I don't know, is Hardenberg something? Novalis was a mining engineer. He had gone to the same school, studied under Werner, and that for a assignment, they said, go map the brown coal. And when Mr. Bossa got there, that's what he did too. So the connection with Novalis. But there's his major work. He's also written another work that I can't say much about because I haven't had time to get into it, and I won't this life, I guess. But it's probably as revolutionary as the first one. You see, if you want exercise, pick that one up. By the way, that's my kitchen countertop underneath, and you see the spherical forms in the granite. That just happened to be there. There's a talk that Mr. Bossa gave, a diagram from a talk on his mineralogy book. So the people in Europe, there's a group in Holland that is studying that book. And Mr. Bossa said, he's not a geologist, really. He's a DDR-ologist. That's Deutsche Demokratische Republik, because he wouldn't join the Communist Party. And so they didn't really trust him to go out of the country much, except to the Czech Republic, which was also communist. So he focused largely on Germany. And he said that really turned out to be a good thing because he went in depth into all of the phenomena. They're all in that book, by the way. He wrote just about every phenomenon you can think of, I think. But Germany is also an unusual country with so many scholars per square mile. They say that every quarry has a PhD thesis written about it. It's very well investigated. And this is a diagram from the book, but it's from a geological map that I bought. I was, kind of blown away. It's a area in the Erzgebirge that we visited. Granite has welled up, and there was some tin deposits. But there's all these lenses within the crystalline schists that they mapped out. I don't think anybody can take that time in America. I've never seen that kind of thing, but this is like also based on the popular, it's on the public geology, is that the crystalline schists are layers that can be followed for long distances, and they've been given names like strata. And within them, you have these lenses, many, many lenses of other rock. It turns out this is right along with the theory that Mr. Bossa had, that all of these substances from the granite up, this chart just does the gneisses. The granite would be below. But these things fell down, and mixed within it were lenses that were in the atmosphere. What would be a good example up here? Amphibole. He thinks that an amphibole lens, for instance, is really basaltic material that fell down later. It was in the atmosphere, it collected itself and came down as a lens within the later crystalline rock. So this idea that these rocks were not like sediments metamorphosed. Instead, this is again a kind of precipitation out of the atmosphere. That's Steiner's idea, is that this early atmosphere actually became thinner by shedding off all of this rock material to begin with. And I'm going to make one last point, and then give a chance for questions again. One of the major ideas that Mr. Bossa has is that, say, during most of the Earth from Cambrian on, the atmosphere was much thicker and the erosion was different. This thick atmosphere would drag across the surface. It would loosen pebbles and I guess it scrape them along and pick up debris and carry it. And the nature of the deposition and erosion was much different than happens later. So this was recorded, he said he found it in the specialized literature about the Permian deposits. So the fact that it had been researched that carefully in Germany, he had the time to find it. I think that was part of being a DDR-ologist. Let's see. The phenomena themselves have led to the situation that in specialized literature, depositional situations must be pictured that lead directly to the images of a moving air-water sphere, even though it might not yet be pictured as permeated with life forces. So he's saying, you look there, the phenomena are telling you that this atmosphere was thicker, it was different. And he reads from it. Sand silt suspensions were spread by highly concentrated dense streams into basins. Thick matrix-rich suspensions. So he sums it up on the next page. All of the phenomena that point in this direction. One, things that I didn't even know, but became aware of, like Arcos, sandstones. I knew that word, but apparently early sandstones have far more plagioclase and other kinds of feldspars that in modern sandstones, they have broken down generally more quickly. There's not as much feldspar. Mica disappears fast, even faster. But in the old ones, there's unaltered feldspars. Then this one really impressed me. There's a lot of anhydrite when you go drilling into the subsurface. And in deposits, this was supposed to be watery. It's sedimentary, right? But anhydrite changes into gypsum with the presence of water. So anyway, so he's able to go through about 20 different points that show that probably the atmosphere was thicker and it was living, it was not water that could be free and chemically active. It was bound up. So I'm going to go on. Okay, I would like to entertain any questions. I wonder what happens if I lower that? Okay. Does anyone, yeah, that's a chance for anyone if you have a burning question. And Barry, I'll depend on you to pick it up.
Okay.
Anybody? Put them
Looks
all
like
to
we're
sleep.
good.
All right. Well, I wanted to get into the geologic column, and this is a fun website. The guy is debunking fundamentalists that think a whole strata, like everything in the Grand Canyon could come from the aftermath of the flood. I mean, they give religion a bad name, but that's the way it is. They think you have to believe it literally. And so he's kind of gently chiding them. Hey, look at this column, geologic column in North Dakota. This could never have happened in 1 year, even. And it's a great article because it's amazing the kind of deposits that you find. So he got, this is this strat column. And of course, they were looking for oil. This was up in the Williston Basin. I think it's around Wyoming. And there's a lot of gas and oil in it. But this is like what a strat column would look like. And interestingly enough, I don't know if we'll have time to do it today. Right before the Cambrian, there was a tremendous period of erosion all over the world. You go down and there's a unconformity, erosional unconformity, and the first rocks are almost always pure quartz. It's worth a topic in itself. But here's the older rocks. There's the strat column that is used today. And now I'm going to relate that I'm going to try to give a fairly quick overview. How long do I have, Barry? Would you say?
Well, hour would be in 15 minutes.
Okay, good. This will serve kind of as a quick introduction to Mr. Boss's book, I hope. This is the back cover where things are summarized. And you're going to see where he thinks that whole stratigraphic column comes from. Here's the soul spirit coming down. By the way, this is the back cover, I think, of the book. You open it up to the back, you'll see this. He's going to go on the front cover, what happens to the species, but he's getting into the rocks here. Rocks are being cast out. The primary rocks, granite, basaltic, granite, gray gneiss, he's timing it. This is for Europe, but goes over into schists. And these are all rocks that have been pressed out of the atmosphere and deposited in colloidal form, according to him. And I would like to read a few lines from Occult Science that I think talks about where this substance comes from. By the way, Steiner gives many descriptions from different angles. And one of the big tasks is putting those descriptions together. If anybody who's tried that knows what a challenge it can be. But primary rocks. So this is from the history section in Occult Science. He talks about a period where human beings, this is after the sun has departed, the earth has become liquid, dense, and human beings are incorporating in a kind of a plant-like way. The soul spirit comes down to a kind of a seed, and he describes well, he talks about how the bodies are built up. The soul unites with this seed-like form, and then it starts absorbing substance and builds up a large body during what would be called somewhere between day and spring or summer. You know, the earth is turning, there's a long light period, and this body builds up. Then a dark period comes, and the body says all that material falls away. And then he points out, if we were to glance at the Earth during its night period, we would see its body in a corpse-like state, for it consists in large part of the decaying bodies of human beings, whose souls dwell in another state of existence. This is during the night period. The organic, watery, and aeriform structures constitute the human body, fall into decay, and resolve themselves into the rest of the earth. So I think this is the period he's talking here, mainly of granite and somewhat in gneiss, and then something's changing. And here he talks about the change that starts happening, that a lot of substance from the atmosphere is being used up. After a time, the souls returning would have found no usable material with which they could unite. All the substances would have been employed in filling the earth with wood-like remains of incarnations. I think this is essentially this hardening granitic and gneissic substance. And then as a result, the present moon withdrew. And as a result, the hardening forces are less. But that is, this is kind of the period of the moon departure. Anyway, I think that's where this primary substance comes from, is the early human bodies when they cast off. And then after that comes stratified rocks. Then as a last, maybe, yeah, the second half or the second part of Mr. Boss's description is how the animals now separate out. So you have here, this is picking up. The rock part is over here, but now there's plant animals coming off, and the human being is still evolving in a soul spiritual form, but various animals and plants are being cast out and form in the different stratas while the human being is metamorphosing. Finally, higher mammals, lower mammals, and then up in the Ice Age, the human beings. So essentially, everything is like a big strat column, that you could say even these are depositions out of the atmosphere. They've fallen down to Earth. And I think at that point, I'm going to say, how about it? Are there any questions now that people would like to pose? And Barry, I'll rely on you.
Okay. I see in the chat, John Petering mentions the topic of colloidal hardening is important to understand. What is the relation to the basic theory of Bowen reaction series?
Okay.
Crystallization sequence of silica minerals as magma cools.
Yeah. It's interesting. Bowen is the classic experimental petrologist here in America.
Yeah,
and maybe worldwide.
John, you can unmask yourself and
Yeah, John, speak up.
Hi. So I think that you've kind of alluded to the first really significant thing, which is to invert the way we're thinking of the earth and the rocks as just mineral physical, rather that the mineral physical is the last stage out of another realm. And of course, from anthroposophy, we go to the spiritual realm, but at least you can talk about the fluid, colloidal, and so on. And I think that's a huge, complete reversal of the way we often think of geology. And then that's why I mentioned the Bowen reaction series, which I think is related to the colloidal thickening and hardening.
My understanding of the Bowen theory is that it was really derived from experimental melts that it is back into the solid liquid gas theories, and not a colloidal process. I remember reading some funny stories between Bowen and Reed in England. He wrote a nice book, Granites and Granites, that talk about all the varieties of granites, and some of them are like, it sure looks like sediments got transformed gradually into granites by something, fluid coming in and doing it. And Bowen would say, look, that's absolutely impossible. Look, here's the theory. I've done all the experiments. And it was pretty icy between them when they got on the elevator, apparently. Nobody would talk. This was around 1940. But
Andrew, your hand's up.
yeah, I'm talking too much. Who else has got something?
No, Andrew's hand up.
Andrew, yeah, what's up?
Sure. You brought up a very interesting topic here about the extrusion of the moon.
Yeah.
And the time frame was, if I got this correct, was in this hardening. And of course, as you know, Steiner points out that one of the reasons for the extrusion of the moon was that the hardening forces were making human evolution on the Earth too difficult. Is this hardening? I assume that maybe it's both, but the colloidal hardening, solidification, as well as the crystallization. I'm assuming that what Steiner's referring to is actually this colloidal hardening. And then along with that, it's funny, I had a book when I was maybe 6 years old. It was a Walt Disney book about geology. And it said the moon was extruded. What's left is the Pacific Basin. And of course, the moon won't fit back into that because the continents, after the moon left, there would have been a big gap. The continents had to drift to fill that space. Any comments on that?
I just take it aboard. I'm sorry, I got distracted. I didn't hear it all, Andrew.
Oh, you got distracted.
Pardon.
I was trying to tell you that what you have brought about colloidal hardening.
Yeah, I remember what you said about the human beings. I think it was just that the material was being extracted from the atmosphere and deposited in a harder form, like a gelatinous form on the surface out of the atmosphere. But I don't think it hardened. That gelatinous form down at the bottom hadn't hardened yet. I think his hardening means that the atmosphere itself was less full of material that the incarnating beings could use.
Mm.
Anyway, that's my take.
Okay. And any comment on the Pacific Basin and the moon?
Oh, that's standard from Steiner, and Bossa goes into it. Yeah, that
Does he? Okay.
yeah.
Thank you.
You know, there's a little bit more I'd like to cover about colloids, if I could, that has to do with hardening. If I can find the right screen here.
Okay, so everybody, we are now at 11:30.
This would take another.
Yeah, so just those who are willing will stay on,
Okay.
and we appreciate your attendance.
Actually, so we should actually shortly open it up to more questions or more broader questions.
People will raise their hand if they
Yeah.
want.
Well, I wanted to give Mr. Bossa came to the conclusion that the granitic rocks were colloidally based. And I wanted to go through the thinking that he used. He started really with what's called oolitic limestone, which is common over there in England, in Germany. There you see the ooids in the limestone, kind of neat, you know. all the different varieties. And he, looking at it, there's different theories. Some people said that was a living deposit, others said it was an inorganic. But when he started investigating, he saw, yes, these were built up like stromatolites by bacteria. If they broke, they might fasten together. They might start growing from the outside around several of them. This was a living process to create these spherical forms. And then, he got, it's similar to stromatolites. There's one, a broken piece surrounded by new growth. This is all limestone. Then he goes to the granitic world and starts finding, they're not common, but they're common enough. There are oolitic granites or orbicular granites. And there's another one. And he took one, this is one from his book. This was, you can see four, you might say, of the central things have been lumped together. It was kind of this granite, this coarse granite is probably the surrounding material. And these are kind of bunching up. But they've gone through process, he said you can reproduce the time sequence. It was like this, built up, broken, built up, built up again, broken again. He said this is a colloidal process like the other one, like the back there, like this buildup that's going on in the crystalline rocks too. Also, this is from up in Maine. They harden at different rates, colloids. So here's a bunch of rocks that were pressed together. It's a conglomerate, but some of them were clearly harder. Some get squeezed almost out of shape, others don't get bent much at all. The minerals are probably pretty similar, but this points to the fact, I think, that some of them had hardened more. These had been colloidal. There's another one. And there are often little vugs in rocks that to me are a point of colloidalism, but I'll get into that later. Often geodes are a great example for me. This is kind of where I convinced myself. The geodes form spherical sections, but they also grow inward in bands. And this one, you kind of see at one point it was compressed, and this black stuff pressed outward. So it was hard. It had hardened, but it wasn't crystalline. And when under pressure, it could flow. Here's one I got. 2 lumps, maybe a third. This was a geode object that was made in limestone, a little bit like the flint nodules in that Seven Sisters limestone. But you can see they've kind of been pressed together into each other. I think what must have happened is the silica collected together within the limestone ooze, settled down, and they kind of bumped each other. And then if you look at the other side, there's the 2 lumps. And to me, this is the little middle piece that was broken out. Probably, let's see, it either floated to the top or it sank to the bottom. But, this silica was kind of gooey. You get that feeling. This was a colloidal silica. And even the Baraboo quartzite, which I love up in Wisconsin, beautiful stuff. When it's pressed, or when it was pressed, it extruded silica out, white. So I think that was colloidal too. And here's the colloidal silica that got pressed out. But the banding is a big phenomena in geodes, and I think that indicates colloidalism. And just recently, I realized that these are Steigbilder, crystallization results from using juice with, I guess, filter paper. This actually has similar banding. I only noticed that, so I'm going to throw it in. Maybe somebody can do something with it. But there's kind of a universal process. I realized this was a soft lump, and it hardened going inward. Stuff fastened to the surface, and probably the interior then became thinner. And finally, it was so thin colloidally that it really was mostly liquid and not much silica. It turned into a solution, really, that crystallized. So what you have is these colloidal forms, and right at the end, it reverts to basically being a solution form, little crystals. And here's another one, crystals in the end, in the middle. And again, it's been, the stuff is being pressed out. I think it's hardened, but not crystallized. And with pressure, it can move. I guess, let's see. This is maybe the last one I'll do. This is something I thought of and I would like other people to think about. I believe this was probably a basalt intrusion that hit something granitic, but the basalt was colloidal and it started, the granite was turned a little bit back into a colloid and the quartz started diffusing out into the darker basalt. But then when the thing finally cooled off and crystallized, hardened fully, that silica that had been drawn out collects together again. And you get something that often looks kind of like a cloud-like pattern. To me, that's silica, and that's a colloidal feature also. And I think I'm going to stop there and turn it over to Barry.
We'll turn it over for further questions and comments.
Well, Barry, we put them all to sleep.
Oh, no.
There's a little feature I'd like to talk about if time allows. So,
yeah. I'm just thinking with that, how to picture that early atmosphere. It almost sounds like glacier erosion and movement.
Yeah, a lot of places have scratched rocks that are interpreted as having been ancient glaciers. And Mr. Bossa said that was probably the being dragged by the life sphere. But that's an open question. That's
So Jeff sends a thank you.
okay.
Anyone else? Okay, I'd be willing to hear
This
more.
is Mark. I actually have a question.
Oh, Mark.
Yeah.
So yeah, I'm just wondering it's very interesting though, these phenomena way back in time. And today, if we look at igneous rocks and volcanism and molten rock, I'm just wondering about these colloids. Are they estimated in any way to be at very high temperatures, or are they not necessarily at high temperatures? Because today, when rocks become fluid, they're usually in a molten state, from a particular standpoint.
Right.
I'm just wondering whether the temperatures were very much different in those days too, and that also created a lot of the colloidal phenomena that then gradually cooled as well. So did temperature play a role in that formation?
I don't think so.
Mhm.
Steiner talks about oven-like temperatures in the past. I don't think it ever got that hot to melt. And the colloids being living from a living source, yeah, I don't know how hot the life could have gotten. I think you can now get colloids deposited from bacteria at fairly high temperatures, like 300 or 400, but not up in the melts, I don't think. Not in the thousands. That's my take on it, Mark. No, I think colloids are a different animal altogether. I mean, there's an attempt to explain them inorganically by saying that they're small particles of solid immersed in a liquid. And you can make colloids that way. And they sort of act like the other colloids, but colloids from life, it's hard to imagine a cell turning out a solid chunk and then turning out some liquid to go around it. I think colloids have to be considered a separate state of matter, actually, for now. At least I do. They act differently.
So, Frank, I have a question. Could this be going on anywhere on Earth today?
Ah, you mean colloidal substance hardening, or? Well,
Yeah.
In Yellowstone Park, when trees fall into the hot water from the hot springs, they're petrified because the silica from the hot springs collects into a kind of colloidal form and penetrates into the plant material, and you end up with a fossil. I mean, yeah, basically it turns into rock, petrified wood. So that's present day. A little bit of that silica is colloidal and working in that way. Yeah. That's what, I mean, that may not be a complete answer. That's what occurred to me.
John Petering again.
Yeah, I just visited the Black Chasm Cavern in California. And in the cavern, of course, they have the dripstone stalagmites, stalactites that are um, common in these kind of caverns. It's a limestone area, the thin layer, a thin band of limestone in the foothills of the Sierras. But interestingly, they have another phenomenon in there, which is that these little formations that grow, and I'm forgetting the name that they call them now, but they grow horizontally out of the wall. And there's a lot of controversy as to how they form, but they're very thin. They're about 2 or 3 millimeters in diameter, and they'll stick out by several centimeters horizontally. And they think that the dissolved limestone solution is moving through there through tiny pores and then crystallizes out on the very end. So they're growing horizontally, which is very strange.
That is
And
strange. Yeah.
and like I said, the theory as to how they form is very hotly debated, according to the docent who led us around in the cave. This particular cavern, the Black Chasm Cavern, in near the town of Volcano, is one of the few caverns where this occurs. It doesn't occur in all the caverns. Interesting, also a little footnote. The reason it's called volcano is that during the winter, when the air temperature outside is cool, the cavern stays warm. And because, of course, the moisture in the cavern, you have high humidity. So the warm, moist air that comes out of the cavern will form kind of a fog bank. And early miners thought, oh, this must be some kind of volcano causing all of this steam. Well, it wasn't steam, it was condensation of the air coming out of the cavern. But the key point here is that this formation of solid material in these little tiny needles, if you will, is occurring through a kind of hardening, maybe not a colloidal, but maybe something similar to it. And yet it's not something that we easily understand.
Hmm. I'll look for that when I'm back there. Thank you. Black Chasm Cavern.
I
And
took some pictures
Chris
and I can send them to you if you want. I think I still have your mailing address.
Yeah, I'd be glad to get them.
and Chris Gupta, you have a question?
Yeah, I was just wondering where is it going in the future? Any projections of what's happening?
What, the development of the geological field
Yeah.
or the Earth? Um, well, I consider Mr. Boss's book to be enough material for 2 generations of geologists to work on. Whether it'll happen or not is another question. The field is crying for workers because I said at a talk once, you can, once you get Boss's ideas down, you can start solving previously unsolvable geological problems pretty quickly. The trouble is you'll never be recognized for it in your lifetime, but you can actually solve things that have been puzzling people for a long time. So whether the future will pick up on it or not, well, who knows? I hope so.
Thanks.
All right.
Yeah, hi.
Anyone else?
Yeah, Walter Goldstein here.
Walter.
Hey,
Yeah, Frank, thank you very much. Quite a picture. I'm still trying to make sense of it. Uh, One of the questions I have, it seems like what we're talking about is a living descending process and the colloidal formation of ground rock. But we have the question of the human being coming down with it. And you showed a little bit of a little picture at the beginning of a drawing by Steiner at different or at different stages of development. How does the human being fit into this? Also, if you look at what the native people say about North America, when they emerged or were here, the grounds were unstable and there were lots. It seems to be lots of disturbances and earthquakes and so on. How does that relate to? So how does more recent human development relate to this deposition process?
yeah, I don't know about those disturbances that the natives spoke about. I guess I'm not going to be able to say much useful about that.
Well, you showed with the Lemurian, you showed a picture of from Steiner that showed a head, basically, with
Okay,
things
let's
streaming
go
from
back
them.
to
And
that.
I'm just sort of wondering, and obviously Steiner talks about the Lemurian time period as being one of great instability of the Earth, right? So
Yes.
with I don't know if it was volcanic, but eruptions, but it seems like there was a lot of instability going on. How does that fit with your picture of Earth formation?
Yeah, well, that probably is around the time of the breakup of Pangea and plate tectonics starting. Mr. Boss has got a section where he thinks a particular part of the Earth's crust was shoved under the Himalayas. It was actually kind of the center of Lemuria. Um, that shifting around is in that time period you're speaking of. But I'm not sure that that's addressing your question, actually. This is the picture I think you're thinking of.
Mhm.
Before and after the Lemurian fall. I mean, excuse me, the mm, Luciferic intervention in the human being. That, if I were to, well, you can read it in Bossa and Steiner, but that period in Lemuria, there's a lot of things going on, and the pictures are different, hard to fit together. One thing Steiner says, there were giant turtle-like, or I've forgotten if he called them, he didn't call them turtles, but creatures on the Earth the size of France, with soft underneath and hard on the top. And you get the feeling this is a description of a microcontinent with the granite underneath and the gneiss on the top. But then he says other places, well, the granite was really parts of like plants, that plant-like forms where the mica was leaves and the feldspar was something else. Then he says again, well, it was the earth was becoming fatigued, and as a result, it was shedding off material. So putting all of Steiner's pictures together, I think, is a task for the next generation of anthroposophical geologists, because they all add to it. And yet, I know one person that was ready to give up because it was so frustrating.
So that might be a good question. The next talk with Michael Judge, I think, will be moving more from geology into human evolution
I
and
believe so,
relating
yeah.
it to geology. And I do also want to point out, Andrew did a note in the chat about those formations that John Petering had mentioned. They may be called helicitites, derived from the Greek word helix. They twist or spiral.
Okay.
And they grow horizontally, diagonally, or in wild corkscrew shapes out of cave walls and ceilings.
Now there's a good puzzle.
Yeah. So, any last question? We're good?
Okay, shall we wrap it up then?
Yeah. And thank you all for being with us, and we look forward to seeing you again
Yeah,
next month.
thank you.
Okay, thank you.
Very nice today.
Yeah, thanks,
Great.
Frank.
Oh, quite welcome, I hope. You think it was worth the time.
Yeah, thank you.
Sure, Frank.
It sure was.
Okay.